The title of the webinar is Optimizing Drill and Blast Operations, an Integrated Solution. So basically, we'll be looking at how you can optimize your drill and blast operations using some of the tools that we have as Hexagon Mining, and how you can leverage some of the integration that we have in our solution. So basically, that's the title of the presentation. I'm not alone, regardless of my panelists, although it might look a bit odd. I've just been given the task of delivering the presentation, but with me, I've got other people from our sister companies that are part of Hexagon Mining. My name is Phumuzo Nechapapame. I'm the technical sales specialist out of the Joburg office. That's me. I'll be doing the delivering. Then we've also got Zigbodi Akoli, who's a senior consultant at BMT. He will also share a bit of his experience towards the end. We have also got Edgar King, who's the product manager for Split Engineering, who did a delivery last week. So he's also joining us. We have also got Bukram, who's also a technical specialist out of the Morocco office. She also comes from my planning background. So basically, that's the team. As I said, I'm the unfortunate one who will be delivering the session. But when you field any questions, all these specialists and experts are available to address those issues that you might have. In terms of the agenda, I'm just going to start by looking at the drill and blasting challenges. Then I'll also just do an overview of Hexagon's solutions in terms of how we address some of these drill and blast challenges. Then I'll go into the deep dive of the technology or the solution, just to show exactly how we have positioned the drill and blast solution in the market. We're going to do a bit of data analytics just to look how we can tie up all the reporting. Towards the end, we will open up for panel discussion and case studies, so you can interact with some of the experts that we have on the meeting. I think if we want us to go into the drill and blasting challenges, there's just so many variables that one needs to understand, and some of these variables are inherent to the conditions that we work. They might be geological, the material hardness that you're trying to blast. Some of them come from an operations point of view. It might be your blast design that needs to be sent to the driller or to the drill rig. How effectively is that communication? Some of the challenges gets introduced when you start looking at the explosives and stemming and all these things that are pertinent to a proper blast. So all these challenges, we are aware of them, and you need to have a very good understanding of this. So once you have done your blast, there is a need for you to quantify the blast or to clarify how the blast has gone on, and to give a account of whether is it a good blast or is it a bad blast. And in most cases, I think it's quite industry standard that we use some key performance indicators. It might be fragmentation, it might be vibration, it might be ore loss and dilution to quantify the performance of our blast. And I think what is critical is that delicate balance between some of these key indicators. It might be fragmentation and ore loss or dilution, which are subject of our discussion today. But all these other factors, your vibration, slope conformance, they also play a critical role in one classifying the performance of the blast. But as I've mentioned, for this session of the presentation, we're going to focus mainly on the aspect of fragmentation, ore loss, and dilution. The benefits of improving your blast workflow it's immense. I mean, if you look at the production benefits that you're going to get by consolidating your processes, if you look at the enhancement in your ore recovery and the reduction in ore dilution and the effect on the grade mill feed, I think the cost aspect, if you've got a good blast, you probably will also reduce your loading equipment, the teeth on your loaders and things like that. And the big one, I think, is the reduction in the mill energy cost, which is also one of the biggest aspects or cost parameters in a operation. Improved safety. I think safety is such a critical component of the mining industry that we cannot properly perform these processes that are so integral in the mine without taking into safety into consideration. So you will see when we start talking about high precision drills and taking people out of the coal face, if I have to use that terminology, how that helps with our safety or improving safety in our operations. I'm going to start by giving a bit of a solution overview. As Hexagon Mining, we have put together a drill and blast solution that encompasses a couple of technologies that has been in the industry for a while. And we have provided a one integrated platform to solve the drill and blast challenge. The starting point of a drill and blast is doing your design. There's a couple of packages out there for drill design. We have our own, which is called Hexagon MinePlan Blast, which helps out with the design. And then once you've done the design, you move on into the execution of the work. We have got our high precision offering, which is called OP Drill, which does the execution. We have also got a couple of tools in there that are critical for managing your blast. It might be the QA/QC process. It might be your vibration analysis using the IDS stuff. The IDS stuff is not subject of this webinar. I think we can look at that in a different platform. What is exciting, or what we have done, we have brought into the fold two very critical players as far as analysis and measurement of a blast or dilution, which is Split Engineering, which we acquired a year or so ago. And recently we have just acquired Blast Movement Technology to close that loop of having the analysis and the measurement of your blast. And I think that's a very, very critical element as far as improving your blasting workflow. You cannot improve something that you do not understand. So the measuring component is quite a critical element. And as Hexagon Mining, having brought these two companies into our fold, we hope that we provide a full-end solution that will allow you to do proper measurement of your blasting and improve on your processes. And the Mine Enterprise platform, which just allows you, it's a web-based reporting platform that allows you to analyze what's happening in the field and to make changes on the go so that you improve your processes. So basically, that's the loop that we have closed as Hexagon Mining, having brought in together a lot of these companies. And I'm going to share a bit of how these companies help us in solving the drill and blast problem. Also, just starting a bit on the overflow of a typical solution that we are putting into the market. Generally, it starts with your drill and blast. You'll have your drill and blast engineer doing the patterns. In this instance, I've just included the scheduling of the drill, because I think sometimes when we talk the drill and blast story, we underestimate the impact of properly scheduling your drill rigs, making sure that they are effectively used. I've just included it a bit also in the presentation, though it's not a subject of this webinar. Once you're done with that, the ideal situation is to release or to export out your collar points to a high precision system. So, which is directly exporting this into a drill rig without having to have a surveyor going up and stack up. I know there's still a lot of operations that use surveyors to go and stack the collar position and things like that. What we suggest in order to control that fragmentation aspect, to minimize the amount of re-drill holes and things like that, is to have the collars released directly to the drill rig, and then the operator will be guided using navigation, can be via GNSS augmentation platform, to the exact location of the hole, and then they will also be guided when they do the drilling, so that they reach the exact depth, that will get your actual fragmentation. What we have also done is to also close the loop in here of bringing back, as you do your drilling, we are able to pull back this actual information into the plan, so that you can reconcile what is actually happening in the field and your design. That's also very critical. Another layer that we have also added is on the QC option, where instead of doing a paper-based workflow where a person goes into the field with a paper and they try to check, the amount of collapsed hole, closed up holes, wet holes, and all that information, you can do it now in a tablet. And when you use the tablet, the advantage of that is that the information gets synced at the same time into a reporting platform, so that you can see exactly what is happening. So in this instance, as you do your QA/QC, collecting your information, it gets reported exactly in real time to your control room, and then you'll be able to see all that information happening. What we've also done is that we are also able to link up to the explosive track. So what generally happens is that as you do your QA/QC, you'll bring in your actual, which is that red line, which is bringing back the actual information, and you start doing your pattern, or your charging and your tying. When you do your tying and charging, you've also got now a platform that allows you now to release directly to the initiators for detonation of your blast. It can be Dyno Nobel or whoever is doing your initiation. And then once you do that, you start, you'll do your blast. And then we have also got an app that allows you to collect the actual blasting information, and then you can also bring that information back into the planning platform, or you can just grab that information and you can also put it into the reporting platform. So generally, that's just the workflow that we are putting in the industry. So what we have added now is post the blast, then you're going to start putting a camera on the shovel or on the trucks to analyze how the fragmentation looks like, and then you can also reconcile that. And then similar thing that you will do with the blast movement, you go and you analyze how your blast has moved during the design. So basically, this is just high level what we intend to do with the solution. Okay, now I'm going to do a technology deep dive just to explain how this looks like. Basically, a drill and blast engineer, you will start by doing your pattern design. You'll be using our tool, which is HXGN MinePlan Blast. You can factor in things like your rock properties, hardness, and all these things that you can use as parameters to do your pattern design. So that's the starting point of the process. And then how does MinePlan Blast do that? It's quite easy, as you can see in this little presentation in here. The tool allows you to create some templates. So you can see you've got some simple templates. You've got some inputs that you can push into the tool. Just give me a second. I just want to make sure the video plays. I've got a little video in there. Oh, sorry. Okay, I have no idea why my video is not playing. Okay, so basically you'll have this is the design component, the design package, which allows you to use some templates to do your design. During that process, you can also have got some inputs. It can be your survey topo, it can be a block model to bring in your geological data. So these are all the inputs that you put into the design component. I had a nice video, unfortunately it's just not playing, that show you exactly how you will do your design. So that's the first point of the process. Once you're done with your design, the next step is to release that that design now into operation. Generally, in a typical operation, you'll probably export out a ASCII file and you give it to the surveyor to go and stake with cones and the things where the drill rig needs to go. What we have with the Blast, it allows you to seamlessly. Just give me a second. I don't know why my videos are not playing. Let's just. Okay, I apologize for that. I don't know why my videos are not playing. Okay, they're much more better. So this is the export component where you'll be able to export directly your design into the drill rig. So you can see there is a Leica export that you're doing there. So it's quite simple. You just need to pick up the pattern and then you hit the export tab, and then that is exported directly into the drill rig database, and then it's replicated into their server, and then the operators will be able to access that workflow. So this is quite critical because you're preventing that layer of importing and exporting data. You're making a bit much more of an integrated workflow. So now you have exported to the field. What will the operator see in the field? The next thing that will happen is that, let me just go one step back. Things are just a bit too fast for me. So this is the exporting. You do the exportation to your drill rigs. And then this is what you will see in your, this is what the operator will see. So with this, there's some hardware that we put on the drill rig, which is our discovery box and a display. So here on top, this is what an operator will see. And then this is all the hardware that we'll put into the equipment. Okay, I'm just gonna quickly. So this is high precision machine guidance. It is using GNS augmentation for it to move the drill rig to where it needs to be. And then, as I said, it's also a direct import of the drill rig from the Blast. We are able to interconnect or connect with a lot of CAD, a lot of industry drill rigs in the industry. So we're able to connect seamlessly to that. So this is what an operator will see on his screen. I'm just going to play a bit of that. So on top here, you can see you will be able to see the position. So on top here, you can see you'll be able to see the activity that he's doing. So in this example, the operator will see that he's currently positioning himself. And then you can see it has just moved the status, and then he has moved to drilling. So when he's drilling, you'll also, here on your right, you'll be able to see the progress of his drilling. So this, you can see here, this is the target that he needs to reach. There is some parameters that are involved in there. In here, you can also see the penetration rate of his drilling. So the operator will be able to see all this information, and then you'll be able to be guided to drill to that length. And the biggest advantage of this is that you prevent under drilling into the bench below, which has got devastating consequences when you go and you drill the next the Blast below. So it controls the bench level. So this is quite critical. The operator doesn't have to use his judgment. He'll be able to be controlled by the drilling. Another important factor is that it also gives him parameters in there. So in here, you can see like the distance. You can tell him exactly how far is he from the design distance, or how close is he from the design distance, or the design meters, or whatever that that needs to be. So this becomes a very critical element for the drill rig. Okay, I'm just gonna. Okay. And the nice part about this is that as he does this drilling, this information is being collected, and when it's being collected, it's being replicated to the onboard database on the drill rig, and then it gets replicated into a server, and then we'll be able to pick up that that information for drilling. So this is a very critical element for you to get proper fragmentation. It reduces the amount of drill holes that you need to do, because you're gonna move exactly to the exact location. You're gonna drill to the exact depth. You'll be able to control the level in which you want to drill. So on top here, other things that he sees, you can see the panel, you can see which pattern is it drilling on, and things like that. So there's a lot of KPIs that you will be able to check. So this is quite a critical component of the solution. Okay, I'm gonna quickly move over.
Can I ask something?
Yes, you can go for it. Yeah.
Yeah, I just wanted to understand that when you are recording the penetration rate while drilling, so can we use this data or this system to categorize or identify the grades of ore grades in a mine while drilling? Can we use this system or data to establish that?
Okay. In most cases, what you will do, or what we collect, is we can collect the compressive strength of the rock. So because you're collecting the compressive strength of the rock, and you know the fragmentation that you need to achieve, you can sort of do sort of a calculation to estimate the hardness of the rock. So you can collect that hardness information, and then you can model it, or in a block model, or bring it into BLAST. I'm going to cover a bit of that when I go into the next tab. So what it allows you is that, because you're using sensors on the drill rig, you will be able to pick up the compressive strength of the rock that you're drilling in, and then you can use that compressive strength to model the hardness. And then once you have that hardness, you can use that hardness to control the fragmentation for future drilling. I'm going to cover a bit of how that works when we go forward here. Okay. So as you do that, as I was saying, you can bring in back the actual information. So in this instance, you'll be collecting your as drilled information, the actual collar position. You bring in as I said, you can bring back the hardness using the compressive strength of the rock. You can bring that back into MinePlan BLAST so that you can change your modeling and do a few things to correct, so that you get the correct fragmentation and you can reconcile. So this video is just a simple video that so in here, it's a bit on Arabic, but what you can see in here, you importing your actual designs. You can also bring back your attributes. So it's quite simple. If you hit on import, so you can go and just say import your actuals. You can import your design, and then you can also just import the attributes. So what this does for you is that you're bringing back the actual data. And when you bring in the actual data now, it allows you now to start to analyze, to say, this is what I've designed. This is the collar position that I need them to go and mine. This is what they've actually done in the field. and then you can start doing your reconciliation. I'm just going to let that play. So that's your actual information. And then you can see that it's overlaid with your design. So when you do this, you're allowing now, you can start to double check to say, this is what I've designed. This is what the drilling has done. Are there any variances? Can I change my patterns? Can I do specific things so that I get my optimal fragmentation? Another thing that you also do is also when you do your drilling, you can also take the app. With the app, it allows you to go into the field, and then you can do a QA/QC. As I've said, instead of you using a paper, you can come in here and you can capture the actual information that's happening. So if it's a wet hole, you can put in a comment. If it's collapsed, there's a couple of things that you can put in there. So the nice thing about the tablet is that if, let's say you've got a hole that has been closed off, you want to add a infill hole, you can also just do it easily on the tablet in the field. You can just go and click a position and say, this is where I need to redrill my holes, and then it will seamlessly do that for you. Okay. So what I've covered in here on this spreadsheet, I've covered the drill. You do your drill design. You release your drill, your design to the field for the execution of the work. As you execute the work, you'll be able to bring information, geological information of the rock you're drilling, your hardness, and things like that. That will assist you in fragmentation modeling. It also allows you to maintain a level balance for your blast, and then you're also able to do the QA/QC, which means you can take an app, go into the field, and then you'll be able to manually put a tape into the hole, and then fill that into a tablet so that you get as drilled information. Okay. So that's the drilling component. Once you've done that, you bring in your actuals now, and then you start doing the tying and the charging. So this, we have also got, as I said, there's a couple of these in the industry, but Blast allows you to use templates to start doing your charging. You start doing your tie-in. It might be using electronic detonators or manual detonators. It doesn't matter. We have got all that functionality for you to do that. But what is very critical, or what is very important when you do your tie-in and charge design, is that this is where you have got your first chance to control your fragmentation. So this is a typical, it's quite one of the most common graphs, I think, in any drill and blast engineer's office. But what this graph basically shows you, it shows you the cost per ton, and then at the bottom in there, it shows you your fragmentation. So if your fragmentation is 5, or if you've got cost fragmentation, and then somewhere in there, you have got your optimal fragmentation. So here at the bottom, you probably have got your this green line. This is your explosive costs. And then the blue line here is your mining cost and your crushing cost. So you can see, my pen is not working. So this is the mining, this is the crushing cost, and then this is the explosive cost. You can see that the finer the fragmentation, or the finer the fragmentation that you're gonna have, it's got a very direct influence on the cost, or on the cost that you have. So the critical element is to try and get that optimal balance, to say which one is the most optimal blasting concussion that I can use, so that I can balance this cost and this cost graph. We can go into details with this graph. I think there's a lot of discussions. And why I've put this graph is that when we do your tie-in and your charge-in, we base most of the modeling on the Kuz-Ram model. With the Kuz-Ram model is basically taking into effect this this model. So this is very critical for you to understand, to see the impact of each of your fragmentation on each of your costs, and what is the implication of that. I've got it a bit upside down, but what generally happens, you can see your crush and grinding costs are quite low if you have got very fine fragmentation. But if you've got very high fragmentation, your crush and grinding costs are going to be very high. Same thing with your blasting costs will probably be much more higher if you are to blast fine. So this dynamic is what is the starting point for our fragmentation analysis. That's where now we move into the design. So when you do the design, that's where, as the drill and blast engineer, you've got your actual from the field, and then you're going to start applying the Kurzram model to predict the fragmentation that you're gonna achieve. See if I can make it plain. I see there's a couple of questions that are coming in. I'm gonna try and address some of these as I go. Okay. I've exited. Let me just restart my slideshow a bit. Let's see if I can play. So this is on the design component. You have done your tying, you have done your firing, you have put in all the blast and the explosives that you want to use. In this instance, in this example, I've got two patterns, which is blast pattern 2 and blast pattern 3. I've tied them in there. I've done a simulation of this is how the blast is gonna go off. This is just an animation, the timing seconds and things like that. What I can do once I'm done with that, I can open up the fragmentation model. So under the fragmentation model, as I said, it's Kurzram that we're using. Unfortunately, we have not yet included the other models into the design component. So in here, what you need to specify is the undersize and the oversize. So you're going to say, this is the undersize that I need to achieve from each of the pattern. So in this instance, you can see I'm looking at pattern 3. This is my oversize that I need to input in there. And then that becomes an input now into calculation your cumulative distribution graph. So this gives you on your design, it models up your fragmentation analysis. It's going to give you your P20 or the mean weighted average that you can achieve from each of the blast. So what's important here is that you can start playing around with parameters. So because in the Kurzram model, what is very important is changing the relative weight of the blasting agents. So the Kurzram model, I think there's a lot of work that has been done by AEL over the past years in trying to estimate that weight. So you can start playing around with different blasting platforms. So you can say, I'm going to load my N4. If I run my N4, what is the profile? What is the mean average fragmentation that I'm going to achieve? And then you can also maybe change that, and then maybe use an emulsion-based explosive so that you can see what is the change. And then that is going to give you an example. In this example, I'm just going to get my P60 that I need to achieve. So this is on the planning side. You are planning your fragmentation analysis. You're planning the fragmentation that you need to achieve in the field. And then you can do that by playing around with your blasting agents and doing a couple of changes. You can change the patterns. You can say, if I've done this pattern, a 2x5 pattern, this is the fragmentation that I'm going to obtain. If I change my pattern design, this is the fragmentation that I'm gonna change, and then this becomes a very critical input into the whole process. Okay, once you're done with that, you're gonna go and start loading the bomb tracks. We have also linked up with, we've got an app that allows you to collect some blast information as you do. So it can be looking at the section view of all the explosives that are being loaded. You can look at the total weight. You can do a cap weight of each of the explosive. So you can do a whole lot of that blast QA/QC before you blast. And the critical information is that this information becomes available seamlessly. Okay, so that's what you've done. In a typical mine, once you have okay, I see a question from Maria. Yes, what you can do on the blast design there, you can change your rock factor. There's a scale on the design there that allows you to move around the rock factor and the density. So the density is based on the because when you set up your blast, they say you can link up to the reserve logic. You can bring in the actual density. So you are able to play around with the rock factor by just using a scale. And then you can also change your density. So Maria, yes, you are able to change that those parameters when you do your fragmentation analysis. In a typical profile, once you've done your blast, you will start now modeling, holding your polygons. What we have done is that we've realized that in most instances, when you do your blast, typically when you do your blast, you want to lift up, that rock and crush it up. But during that process, there's a bit of movement. It can be lateral movement of the polygon, and that's where BMT comes into the play, into the field. So I'm just going to quickly play this BMT video. It explains exactly what BMT does for you, and then I'm going to talk through it. Okay, it looks like the sound is not coming through. So let me just go back. I'll just talk through the solution. So basically, a BMM is a little ball that the ore control engineer will play around with a bit. So what generally happens is that when you have done your pattern design, the ore control engineer will load into. Yes, I did hear that there is no sound. I'm gonna talk through the workflow. So what generally happens is that the ore control engineer is gonna go and design other strategic holes using the BMM software. And with those strategic holes, so these are the strategic holes that you drill in your pattern before you do your blast. So what we do, we take that little ball and we put it inside. Okay, I see there's a lot of questions in there. I'm gonna address them as we go so that I can move on with the solution. So in this example, you're gonna come in here, you're gonna activate the BMM. Once you have activated your BMM, you're gonna put it into the holes. So this is an example. You can see it's activating his BMM. You're gonna put it in those strategically created holes. Then as you blast, the ore is gonna shift. And when it shifts, also these balls are also gonna shift accordingly. After that, what happens is that you're gonna bring in a post-blasting team to come and locate where those little balls are situated. So these balls are consumables. You don't retrieve them. Once they are blasted, they are gone. But what we did, we just need to go and locate the location of each of those blocks. So once we locate that information, so you can create a new post-blast polygon. So you can see here on the software, you will have the polygon in there. And then you can calculate a new polygon based on what you've collected in the field. And then this allows you now to calculate your ore loss, dilution, and all those factors. Okay. So this is just the workflow that I've explained a bit. You'll probably have these blast movement monitors. You're going to put them in selected holes. And then this is all the hardware that you will need for you to go and track where each of those balls have moved to post blasting. Okay. So the critical element now, I've spoken about 3 technologies. I've spoken about the blast design. I've spoken about high precision. I've spoken about blast movement. I've spoken about split engineering. How does all this information now add value for a client? In this example, you can see I've got my BMM software in there. In this example, let me just activate my pointer, my pen. So in this example, this BMM software now becomes your input into your scheduling. So instead of you taking the polygons that a grid control engineer or geologist will give you, you're gonna take now the pre-blast or the post-blast polygons, and then you're gonna use that into scheduling your dig. There's a very close relation between what BMM is doing and what the ore control engineers are doing. So the ore control engineer will give the BMM. This is the planned polygon, and then BMM will put out what we call a post-blasting polygon that you can use to shadow. Also, what happens is that you've got your monitoring that you're doing here with the split shovel and track cam. So what you do, you have got, as you load, you have got a camera on a specific area of the bucket. It can be on the truck or on the shovel. As you collect that actual data, you can also bring that data back into planning, or you can also bring it into the block model so that you are able to model a bit more of the fragmentation. So this is where we are doing, or we are closing the loop, where we are collecting actual data, and we have taken that actual data and we are modeling it, and then we modify our drilling accordingly. So basically, this is the workflow that we do. A good example. This is the example that I spoke in. I'm just gonna go and speak a bit onto that. Let me just see if I can erase that. So this is the split shovel example, where I'm gonna start bringing in my actual fragmentation back into the blast and then back into the block model. How do we do that? As you take that information we've got what we call the split desktop. So split desktop allows you to analyze the fragmentation, or the grain size of each of these bucket loads. In there, we are able to export out some of this data. Right? In this instance, we are not yet fully integrated. We can export out that split data, and then you can bring it now into MyPlan Blast. So you see now what you're doing now, you are bringing the actual fragmentation data into MyPlan Blast. And then remember that Blast on its own has got a Kurzram model that it used to estimate the fragmentation. So based on these two, you'll be able to say, this is what Kurzram is saying. based on the pattern that I've specified, based on the 8 blasting agents I'm using. This is what I'm supposed to do. When I go into the field, am I able to, this is what happens when I go into the field. This is what split engineering is saying. And then you can reconcile the two so that you can see the effectiveness of your fragmentation design. I think the closer you have split engineering to KUSRAM or to the blast design, I think the better your fragmentation that you will be and that you will achieve in the field. So we're able to bring that information in there. So this is an example of split engineering data, fragmentation data that I've imported back into BLAST. So you can see all those. Okay, I see there's a lot of questions. Unfortunately, it's a bit tricky for me to field all of them. I'll try and get back to them so that I can quickly go through the content of the presentation. Okay, so what you do in there, it will bring in your fragmentation. Okay, so the questions are a bit curious. Okay, so what you can do a contour of your fragmentation so that you can see exactly how the fragmentation post blasting looked like, and then you can start adjusting your designs for polygons that are quite critical. Another very important thing which now links up or ties up everything nicely is that you have done your fragmentation analysis from split, but what you can also do from the high precision drills is that you can also, because you're collecting I've already mentioned this, the strength of the rock that you're drilling with, you can kind of estimate your hardness, and then from that hardness you can do what we call hardness contouring. So with the hardness contouring, you basically take the high precision drill information, and then you can contour that information. So that you can see how the hardness profile looks like. And once you have that information, you know that when you go and you drill into the next pattern, this is the hardness that I'm likely to experience, and then I can go and modify my blasting agents, my pattern, and things like that by tying up that information. So these two are quite critical in post analysis, in optimizing your fragmentation and in making decisions quite quickly. This is also another thing that we generally do, is that you can also bring in the split engineering data. You can bring it into a drill hole management you can bring it into a drill hole management database, and then you can sort of composite, and you can build a sort of a fragmentation block model. And then from that, you can also use that fragmentation block model to analyze how you can better optimize your drill and blast solution. So this is where now we are closing up the loop. We are grabbing actual information. We are using the actual information to model and to predict fragmentation. Okay, another reconciling factor, as I've said, is also coming from the BMM side, in which you have got, you can reconcile what the grade control engineer or geologist is specifying with what has happened post the blast. So you can open up your BMM Explorer software, and then you can load or you can superimpose the pre-blast polygon ore, and then you can overlay the post-blast ore. So what this allows you is that you will be able to identify areas of potential loss, areas where there's going to be a dilution post the blasting, and then you can also identify areas that have got misclassification of material. So now this becomes now the source of your routing or your holding of your material. So you're going to use the post-blast ore classification now to go and load, and in that process you'll be reducing your dilution and your ore loss. So this is just one of the aspect of reconciliation that we have. Another final piece of the Django, as I'm going to be finishing off delivering the solutions, that we also bring or tie up all this information into an enterprise reporting platform where we can bring all this information into a tablet or into a web browser where you are able to analyze what is happening in the field. We can integrate that data. For drill and blast, that's quite easy. We can do that easily. The block model data, fleet management data, machine guidance data, we can do all that work. So future work, we probably will look at using proper fragmentation analysis, and with the acquisition of BMT, look at how we can do that always dilution analysis. So this is how the BLAST module looks like. Let me just end my options there. There is, I see there's a question from Emmanuel about reducing vibrations. As I said, we have a solution from the IDS, from IDS that helps with that. But also on the design side, Emmanuel, we are also able to kind of model a bit of the vibration. We can choose specific location where you want to put in your monitoring devices and things like that, and then we can try and simulate a bit your post blast vibration. But there is an actual offering from IDS that assists with the vibration analysis. But as I said, we can always get back to that at a later stage. Okay, let me just see if I can play this video. Apologies for that again. Just quickly go in the slideshow. Okay, it's much more better. So this is the enterprise reporting platform. This is the drill and blast modeling component. So you'll be able to see the location of all your drill holes in the field. This is just an example. It's also color coded, so you'll be able to see holes that have been drilled, holes that needs to be re-drilled. You can also see the location of all your equipment. So this is just an example. I can see all my holes. Also, a very important factor of the tool is that it also allows you to also design holes on the fly if you're in the field. So in this example, let's say you want to do a specific change in the field, so you can quickly add a hole in there. So it's very interactive. It allows you to do specific changes using an app. So in this example, I'm going to just select a few holes in there so that I can edit them. I can also just add an extra hole if I need to. So this is just some of the things that you can do with the drill and blast module. Then it also has got a bit of the reporting capability that gives all these reports to stakeholders in the field. So in this example, I'm just going to look at the blasting report. So it's going to just show me a bit of drill depth variation or deviation. I can look at my stemming variation and things like that in the report using a web-based platform. I can also just open up my drilling and just check out how my drill has been performing. So in this example, I'm just going to go and choose up, let's say, a specific equipment, drill rig 01. I can see who was operating that drill rig, the design depth and the drill depth. I can also just see the status of each of the holes. So this is what the enterprise level reporting allows you to do. It allows you to see this information in near real time, and so that you can make the changes as you go. As I said, we're working on also bringing in some of the fragmentation data into the platform, so you'll be able to see sort of your average fragmentation per day, per block, so that you can also take specific decisions in the future. We have also got heat maps, so it will just create sort of a fragmentation heat map in the pit, so that you're able to see areas where, or polygons or areas that you were not able to achieve an optimal fragmentation. This also allows you to modify and do changes into your design. Okay, from my side, I've done what I wanted to show. The next step is just to go through a bit of the case studies. I think we still have got a few minutes to do that. Any questions on what I've shown before we go into the case studies? Are there any questions that you feel that we need to address?
Pumuzo, we can go through some of the questions that you were posted while we were
yeah, I'm just going through some of them in there so that I can see. Okay, from Gilberto, he asked if there's any other fragmentation model. As I said, we are unfortunately on the design component, we have not yet included some of the models. It's probably something that we'll look at in the future. And then Deepashu said Kuzram is widely popular, so that's fine. For fragmentation, such as, I've answered that. I did say you can play around with the rock factor by moving a scale. The rock density you can also change up in the blast, so that that will allow you to do the calibration of your fragmentation analysis. There's also a question that if it allows for sleep time of explosives, I just need to, and strata blasting, hot strata blasting, I'll just need to verify that department for you. I'll get back to you with that question. I just need to quickly verify that. Is there a better place to place the holes? That's from Ruiz. I think it depends. I personally prefer, if you're asking from the design point of view, I prefer putting my holes on the top because it allows me to drape the holes into a topo much more easily. So when I do my blast design, I generally put my collar position on top because it's just much more easier for me to say these are my collars, but can I drape them into a topo so that I am able to model the proper undulations. I think Zigbody has answered that. This is also answerable. Can you please share how the mine plan provides the results on P80 before them? Is there any yes, as I said, we are using the Kuzram model to get that mean average fragmentation that you can get. So yes, we are using Kuzram to do that. Okay, some of the questions I'll probably get back to you. In the absence of further questions, I'm just going to ask my my panel, which is Edgar, to please join. I'm going to share my screen now, and just share a bit of what you did in one of the gold mines. It was a pit to port optimization project, and then we take it from there. So I'm just going to start with Edgar if you can unmute yourself and just share what you did at this mine.
Great. Can you hear me? Hello?
Yeah, we can hear you, Edgar.
Excellent. So this was a typical mine to mill or pit to plant optimization project. It was done in a gold mine in Africa. They put cameras throughout the process, but the ones that were in specific use in this case study were those that were measuring the material going into the primary crusher and then comparing the material that comes from the crusher discharge. So you can kind of see how much fragmentation is just coming directly through and moving through the process. As you know, a pit to plant process requires that you do some more additional work in the blasting stage. So there was an increase, it was nominal increase in the blasting costs. But what that resulted in was a 10% increase in throughput. And at the current gold price, you can imagine that would be quite a significant benefit.
Okay.
So again, this is just that same philosophy you were talking about, which is taking your measurements and then feeding it back to the blast. So controlling your blast and improving your blast to get your benefits through the process. Thank you.
Okay. Thank you, Edgar. I'm going to ask Zigbodi, if you're around, can you just share the value proposition that was done at the KCGM gold mine? If you can unmute yourself, Zigbodi.
Okay, thank you, Kumoji. Can you hear me?
Yes. Yeah, we can hear you. You can go ahead. Yeah.
Okay. So this is a case study from KCGM. Basically, KCGM is Kalgoorlie Consolidated Gold Mines in Australia. Yeah. Actually, they started a trial in 2006, but when they started, they were not using the BMM for all the blasts, and they got to a time they were modeling the blast with the little data they've collected. So we advised them that no, that will not help, and their reconciliation has been bad from 2007 to 2008. So they contacted BMT as a blast movement monitoring to improve mine reconciliation. It was identified as a project in the business plan for the geology team. That was in 2008. So we did a trial. This time around, we did extended trial from 2008 December up to somewhere June in 2009. That was about 6-month trial. So the system now was implemented, and then they started using it. You know, it is difficult to sometimes ascertain the impact blast movement has on the mine reconciliation. Normally within any mine, there are potentially a number of different variables that can affect reconciliation. In the case of KCGM, they are having an issue of a long residence time of ore within the stockpiles. That means the material keep long on the stockpile before they are fed into the plant. And they have a complex number of mill. That's at any time, a large number of gold can be locked up in the circuit for a longer period, or sometimes on the stockpile. So doing a monthly reconciliation is becoming a big problem. So they decided to do a 3-month moving average reconciliation. So that's what is shown in the chart. So after the implementation, the system has improved drastically from 2009 to 2010. And then this was published in the 8th International Mining Geology Conference. They said that it was estimated at 0.09 grams per ton of gold increase in head grade over the period in 2010. That had resulted in 24 million. This is a benefit to KCGM. So this is the graph showing the 3-month moving average. So the implementation was done somewhere in July And then from that time up to 2010, we could see there's a lot of improvement in the area reconciliation. And this is another value proposition from Red Dog. That's a zinc mine. They also implemented a system, and then they published this. That was in 2018. They said that the blast movement has improved their system, and then they estimated around 6.5 million annually. That's the amount they are making. Meanwhile, they spend only 160,000 USD in a system for an entire year. Yeah, and then this is a quote from one of the geologists. The information we get from the blast movement sensors allow us to track the ore movement of ore in greater detail than even before, leading to improved productivity and sustainability at our operation. That's what is said by Brian Hill. Actually, this was published, so we are free to mention their names. It was published in 2008. So these are some of the success stories. If you want more of this, you can visit our website. You go to blastmovement.com. There are a lot of case studies on our website. So basically, we are saying that blast movement is becoming a standard for all movement. Okay, thank you very much.
Thank you. Just to cross off, this is another good case from Mesquite Mine. I think it's somewhere in North America. I think when we did this project, it was still owned by New Gold. I think they've subsequently sold the mine in 2018. I'm not quite sure of the current state of affairs there, but it was quite a good project where they wanted to improve their linear deviation of drill hole collar locations. And what they did, they acquired not only the drill rigs or the high precision drill equipment. The backbone of their system was our blast solution, which is HX GM Blast, which was being used to do the blast designs. And release that for execution. So the process, it started, I think it was in 2015 May, where they bought some of our high precision equipment. As I've shown you the hardware that you need to put in. In October 2016, I think that's when we started to install some of the work. In January around 2017, that's when we started to transition the system into full production. But what was amazing is that once the case study is quite long, I don't have time to go into the details of each of the aspects of the detail. But what they did, they used our drill and blast, did that for designing, released that into high precision. They analyzed that prior they started the project, this was the whole deviation that they were getting without our solution. We ran a trial from 2015 to 2016, and then we analyzed the results to say, now if you start using HXM Blast and high precision, what are the kind of results that you can use? So they could do the design, bring back the actual, as I've shown in my description of the solution. And there was huge improvements in alignment or in deviation that they were trying to track. And this is just a high level number of how they judged the success of the project. They said in 2015, prior installing Blast and high precision, this is the amount of tons that they blasted, and these are the amount of holes that they were drilling. So you can see there was probably a lot of re-drills, a lot of issues because of the deviation issues they were encountering. But in 2016, prior or after installing this combination of HXM Blast and high precision drilling, they were able to still get, blast similar amount of tonnage, but with a reduced amount of holes that were being drilled, because they managed to reduce the redrills and all these things. And I think the cost saving for them was quite staggering. If you do need a bit of this case study, as I said, I cannot go into the step-by-step process of what we did for them and how we solved the challenge. I just thought maybe I can just show this cost saving that they achieved within a year by adapting our solution. Okay, in a nutshell, I think that's what we had to share with you guys. We have went overboard by about 11 minutes. I think it is just the breadth of the solutions that we have covering. And I think maybe just in closing is that what we have shared for you, these are solutions that we're working as point solutions. But what we have done, there are mines that have got all these platforms, that have got our mine plan drilling, mine plan design component, that has got high precision, that have got fragmentation, that has got BMT in them. And I think we are going to be tirelessly working into trying and integrate this into one value proposition so that you can gain what the mine that Edgar mentioned gained. You can gain what BMT did for KCGM, and you can also gain what Masquerade managed to gain in one go in an integrated platform. I think that's the biggest value proposition that I want to leave with you today. And then if there's any other questions, you can drop them to me directly or to one of the people who organized the seminar, and then we can answer them from them. Thank you.